There we go. All right, we're live again. Hey, everybody, welcome back. Welcome back to Eric MD. It's nice to have you back on with me. It's a beautiful Sunday night. We're August 9th of 2020, still in the middle of a pandemic. But nice to see you all. Welcome back. Uh, I hope everyone really liked the CBD series that we just finished. I hope you learned a lot about the topic. Again, kind of our goal was to educate you on what CBD is and how it works, so that you can make some good decisions. It's a really popular thing going on right now, so hopefully you learned a lot. It was awesome having Mark on to give us some different perspectives on some of the business side and some of the science side. I hope to have him back. After we spoke, he told me there's some other cool things coming down the pike with CBD and kind of the cannabis chain or strain of plants. So stay tuned for that. We're going to have him back on. Let's see, a few people are logging on. Hey, everybody, welcome. If you're on, you can say hi on the side there. Hey, how's it going? Deidre's on. How are you? Please say hi. I can see you. I'll try and answer questions as we go. This time, this is a pretty cool topic. Tonight, we're going to talk about COVID-19 testing. I know, again, everyone's kind of COVID and coronavirus are really all in your face these days, which I get. But testing is really important right now, especially with back to school happening right now. Workplaces are opening up. Testing was and will be pretty hallmark to this whole pandemic, right? So it's really nice to know all the different types, kind of how they work, because they're not all the same. They do different things. Okay, so that's what we're going to focus on tonight. I'll keep it pretty short so everyone can kind of get through this and understand a lot about COVID testing. Again, a quick disclaimer. This is not a substitute for official medical advice. This is just for educational and informational purposes only. Okay, and again, I'll go through all these from what I know and kind of explain and break down the different types of testing. If you have a question, please ask. I'll get to as many of these as I can. Okay. All right. So let's go right to it. So there's three main kinds of testing. Okay. There's a lot going on with this, so we're not going to go into the nitty gritty of each different kind and the weird types. But for all intents and purposes, there's three main kinds: PCR, rapid antigen, and antibody. Okay, so we'll go over the basics. Again, how they work and how you might use them. Okay, let's go over the coronavirus a little bit because that'll help us understand the testing. It's called coronavirus because of these little spikes on the outside of the virus. If you've seen the pictures, it's pretty true. They're like a little ball, and they have little spikes on the outside. That's the corona or crown of it. They're actually proteins that help our body identify what it is. Now, interestingly enough, there's other types of coronaviruses. That's why this disease is called COVID-19 or coronavirus disease 19, started in 2019. There's other types of coronaviruses like the common cold. And a lot of you have heard of SARS, right? That was like the bad disease a couple years ago, severe acute respiratory syndrome or SARS. This one's actually SARS-CoV-2 is the official term. SARS is because it's acute respiratory. CoV is coronavirus, and it's the second one. So not rocket science here. So that's the official term of this disease, SARS-CoV-2. Okay, the number one was the original SARS a couple years ago. Those little spike proteins are really going to come into play with the testing. Okay, so let's start off with PCR. It's the kind of gold standard. It's what everyone is probably familiar with. It was the first one they came out with. PCR stands for polymerase chain reaction. Okay, don't need to know what each one of those means, but we're going to talk about how it works. Basically, the virus has its own DNA. It's kind of a living organism. There's been some debate about that, but it actually has DNA. So what PCR does is it makes millions of copies of the DNA, and then a machine sees if it's there. Okay, and that's why it's so accurate. So, and it's actually a cool reaction. For those of you who are interested in biology and DNA, DNA has two strands, right? You got the strand over here and strand over here, and they're connected. So what this does, this reaction, it actually unzips the DNA, and then it copies one side. Now you have two strands. So you have one, and it copies it into two. And what they do is that's done like a bajillion times, and so a bajillion copies are made. And then special machines or other ways, there's older ways to do it, will detect its presence. Okay, so again, that's why it's so accurate, because it just tests to see if there's any DNA. And even if there's one tiny strand of it, it'll make a zillion copies, and then all you have to do is see if it's there. Okay, so how does this test for coronavirus or the COVID-19? You get the little nose swab. For those of you, a lot of people by now have had the really awful nose swab. You get the cells directly from the respiratory tract. That's where the viruses like to live, right? So you put the swab up there. The swab is put into chemicals. The chemicals will dissolve everything. They'll dissolve the boogies, as my daughter refers to them, the cells, and even down to the virus. They'll dissolve everything, right? Down to the DNA. And so then the PCR, polymerase chain reaction, is allowed to happen. So again, you take the boogies, that's what she calls it, it's so funny, and dissolves it all the way down to the DNA. This reaction is allowed to happen. So you take even if you get one strand of DNA, you replicate it a bajillion times, you're gonna have it. And then you put it into this fancy machine or other detection device, and it says, "Yep, it's there," and so it's present. The good news is it's the most accurate test, right? Because you're testing specific DNA. So the scientists came up with the little reagents or markers to find it. And so that means if it's positive or negative, that's probably going to be true. Because if it's not there, you didn't make a million copies of it, you're not going to see it. If it's there and you do make a million copies of it, it's definitely there. Downsides to this test are the turnaround time, for the most part, due to this reaction that needs to take place. Science has advanced quite a bit, and the reaction can happen pretty quickly. But for those of you that can attest, the test can take a long time to come back, right? They're testing thousands and thousands and thousands of these a day, and to allow this chemical reaction to happen the right way, it could take a long time for that to come back. Now, that's not the case for everybody. There's some private labs that will do it right there for you with a couple hours, within a couple a day turnaround or so. But the reaction takes a little while to happen. That's hence the long turnaround time. There's something called a false negative, which means it comes back negative, but it's not true. It really is positive. That could happen in this test, but usually it's because the sample wasn't good. So if they didn't shove that thing all the way up in your nose and get the good cells, that could be what's called a false negative, meaning the test came back negative, but you really have the disease. Otherwise, the test is pretty accurate. Okay, so that's what PCR is. Oh, here we go. I'm going to go ahead and look at some questions here. Lower nasal swabs accurate is the higher swab. No, they really got to get up into what's called the nasopharynx. It's actually kind of gross, but your nose right in the front, the cells don't really live there, or the virus doesn't like the cells right up here. Plus, the way the physiology of your nose works, it really, when you create snot, it pushes everything forward. You want the live stuff in the back. That's why they have to almost go touch your brain. So again, then there's less like snot and stuff. We're going to using real words here, right? There's less snot to get if you go all the way in the back. So they're working on some lower nose swabs, but right now the one that goes all the way up in the back, it's called the mucosal cells. That's just what it's called. If you really get a good brushing of those, that's where the virus is more likely to hide, right? I have another one, so that's Lisa and Zach. The less classy spit test. Yeah, actually, interestingly enough, they are coming out with one of those. Not that you just like spit into a dish, but it's called a buccal swab. Buccal is the fancy medical term for in your mouth. So the swab right inside your cheek. This is a classy show, by the way. A swab inside your cheek, and you can test for the virus in there. But again, the reaction takes place. The more pure the sample of just cells, the easier it is to break down. So in the mouth, they have to break down the saliva and other stuff that makes it a little bit more difficult to do. But there is a company, I believe, I forget how far along they are, but yes, there is one coming out where I don't think you can just spit into something and they test for it, but they can swab the inside of your mouth for it. Okay, so let's talk about the rapid test. So that's the popular one right now because it's quick. Instead of waiting 2 weeks like some people have for the PCR, due to the length of testing, you can get a rapid test. So the PCR is what tested for DNA. The rapid test tests for something called an antigen. So we talked at the very beginning here about the little spikes on the top of the virus. That's a little flag that tells the body what it is, right? It's like a little marker. The body's floating around going, what is that? That little spike is specific to that virus, so it knows what it is, and we call that an antigen. So that's what that test does. A rapid antigen test, they created a lab-based antibody that knows that little protein, that antigen, that spike. And so when you test for that with the nose swab, you also have to shove that thing all the way up in there. But it's quick because they have a lab-made antibody. It attaches to the spike protein or antigen. If it's there, boom, you're positive. Okay, and that can be a lot faster reaction than making a zillion copies of DNA. Now the benefits, again, it's quick. The results coming back, and you've heard probably like at 20 minutes, an hour. It's real fast. The downside is there's a lot of false negatives, meaning it came back negative, but you're really positive. So for those of you who know epidemiology, it's something called sensitivity and specificity. Sensitivity is its ability to pick up active disease, and specificity is its ability to rule it out. So it's not that sensitive, meaning you could have the disease and it doesn't pick it up. Okay, so that's a little concerning, right? It can miss positive cases. The reason is you have to have a really good sample, and you're not making a gajillion copies of this little flag, this little protein that's floating around in there. You have to have a really good sample and a lot of virus. That's the other thing too. If you're just kind of early in your course of the disease, and the swab only got one little virus particle, and he kind of evades the antibody, it's going to come back as negative, right? So you're going to have a lot of false negatives, which is frustrating. Again, a lot of you who have been exposed really want to know, are you negative or positive? The test comes back negative. You're like, hello, that's awesome. Yay, high five. I'll high five myself, but you get the idea, right? So you then have to confirm it with the PCR, right? That's frustrating. If you have to do two tests, might as well just get the PCR. The only benefit of the rapid antigen test is that if it's positive, it's almost always positive. So if you kind of have a little bit of the flu, or you don't feel good, you're pretty sure you have it, and it comes back positive, you pretty much got it. So again, epidemiology, it has high specificity, which means if it's positive, it's pretty much definitely positive. It's not going to be, a whiff. Again, it's not 100%, but it's pretty darn close. So if you're just trying to rule it out, not the best test because it could have missed it. Okay. Again, the PCR could take up to 2 weeks, which is the amount of time of quarantine. So a lot of people will get the rapid one and the PCR on the same time. The rapid one will tell you probably negative, so that's nice, but then you still have to wait for the PCR. All right, is that all making sense, everybody? We have a lot of people watching. I appreciate y'all watching. Please share this and ask questions. Cool. Let's go to the antibodies. This is the new-ish one that's becoming more popular. It's pretty simple. It's a test to see if your body made antibodies. Okay. Antibodies are created by certain cells in your body that are, again, like little tags that they'll go and float around and attach to the virus and tell the troops, hey, this is what you're supposed to kill. Send the troops and they'll destroy the virus, right? So if you're going to get an antibody test, or you have gotten one, you'll see two types, IgM and IgG. IgM basically shows you active disease. So IgM antibodies produced when you're actively fighting something else. It's like a hand grenade. It'll throw in a label. That's the problem. Go get it. IgG, for the most part, is showing you if you have had it before. So it's kind of protective. They'll float around for a while as kind of sentries, guards. They'll float around for a long time, and if you ever get the disease again, it'll attach and signal the troops to come kill it. Right? That's the difference between IgM and IgG. There's ways to do this. Again, they can do it from the swab in the nose. They're working on the one in the mouth. There's a newer one where you can prick your finger and do it from the blood, which is much better than nose mining. Okay, but a couple problems here. It still doesn't catch some positives. So again, it doesn't have a high sensitivity. The reason is because you have to actively be producing antibodies. The human antibody response can be delayed up to a week or two. So if you just got exposed, 5-6 days ago, and you may not have symptoms yet, you get the antibody test, it's negative, but it's because you haven't produced antibodies. Even the IgM, which shows active disease, it really takes a huge immune response for your body to say, uh-oh, I got to make some of these antibodies to label it. And again, also, if you're asymptomatic, that's a big issue, right? If people are not symptomatic from this, you may not be making a lot of antibodies. So you could have it and not know it. Okay, so you're going to have some false negatives behind this. The other problem is the IgG, which is the protective one. If you've had coronavirus, COVID-19, and you get your antibodies checked and you have IgG, you're like, oh man, I guess I had it, but I feel better now. That's cool. The big debate now is how long are those protective for? A lot of us, if we've had a cold or other types of things, we have these IgG antibodies that could circulate for a long time and potentially keep you protected lifelong. The IgG antibodies for COVID-19, we're not sure, and most recently they said maybe only a few months. So if you get the IgG positivity, you may be protected. We don't know how much. Could you get it again? Maybe. but it may only protect you for a few months, which is very frustrating, which is kind of what they're looking at for vaccines right now. The vaccine is to produce some sort of a mixed response, T cells and antibodies. But if you get a IgG antibody response to the vaccine, but it only lasts 3 months, that doesn't do you very good. Okay, so that's the antibody test. Hope that makes sense to all the types of tests we talked about. PCR, gold standard. Again, it's taking a strand of DNA and making a bunch of copies. So it's a really good test because if you only have one tiny piece floating around, this test will catch it and will detect it. But it's a long turnaround. The private labs, again, now are doing a better job, but it's because the reaction takes a little bit longer. The rapid test, so if you go to a place where they say, oh, you'll get your result back in an hour, and you ask, is it a rapid antigen test? That's just testing for the little protein, the little spike ball on the end of on the edge of the virus. It's a good test to see if you do have it. If you think you have it, it's positive, you got it. If it's negative, it might have missed it. Doesn't always, but more often it will. I think it's about, again, depends on which company you get, but about an 87% chance that you got it. So that's one of the downsides to that. Even though it's quick, it's nice to see. And then antibody, again, is good to see if you've had it before. What does that really mean? We don't really know. And if the IgM is positive, that means you're probably actively fighting it off right now, but it could miss too. If you haven't produced antibodies yet, if it's too early, or if you're just not generating a huge antibody response to it, then it might come back as negative. So right now the recommendations are if you want to get antibody or the rapid antigen, that's great. But if either of those are negative, you still have to rule it out with the PCR. So again, not rocket science here. That kind of tells you PCR is still the best to go for. Okay? All right. That's all I got. I hope that was informative. Try to keep it a little bit shorter tonight. Any questions, please write in. You can do it now or you can do it later. Again, you don't have to watch us live. But you can ask questions if you do. All right. Thanks for tuning in for this one. Suggest more topics on the Facebook page here. Again, there's a little form that you can fill out. I'll post a new one that's independent of the CBD where you can just post some suggestions for new topics. For those of you who've suggested a few, I'm staying away a little bit from the eyes right now because, again, that's what I do every day. And we can hop into some eye stuff soon, but trying to keep things relevant. If you're a doctor, healthcare provider, nurse, whatever, and you have a good topic and you want to be a guest, please let me know. I had a lot of fun with my brother Mark on talking about CBD. Again, this is really informal, so let me know. Especially, I'm looking for pediatricians who want to talk about school stuff with COVID-19. Okay. Next week, we're gonna switch gears quite a bit. Okay, so we did some eye stuff, and then we did some coronavirus stuff. Then we did CBD, which is cool. This is testing. So next week we're gonna switch gears to some basic disease stuff. We're gonna actually talk about diabetes. It's not a sexy topic. I get it. It's not about coronavirus getting into your eyeballs, but it's one of the most prevalent diseases in the United States. And even more now than ever with people not necessarily taking care of themselves, being under quarantine, people's sugars are going real high and they're not doing well. So we're going to talk maybe two-part series about diabetes. What is it? How's it treated? And complications. Okay, that could be very interesting. You go into stuff like your eyes, your kidneys, all this other stuff to do with diabetes because either you have it or you know somebody that does. So we can't forget all that stuff. Okay. Oh wait, a couple more stuff coming. So if the antibody here, Zach says if the antibody test is negative for IgG and IgM, does that mean you never had it or is there a shelf life? Yeah. So IgG means if that's negative, then you probably never had it. IgM negative means you're not actively fighting it off. But again, they can whiff, they can miss. So one example is if you had it, but it was a really mild case and you had no symptoms and your immune system just kind of went, don't care, and never produced antibodies, then you technically could have had it, but you tested negative. And to your point, is there a shelf life? They don't know. They're thinking only like a few months. Now, given that it was February, March, April, May, June, July, it's been going around for 6-7 months. Technically, you could have had it when it first came out. Now your antibodies are already negative. Again, that's unusual, but more than likely what you're going to see is you'll be really sick and you'll test maybe positive, and then a month later you get your antibody test and the IgG will be positive and the IgM will be negative, meaning you've recovered, you're not fighting it currently, but you had it. So to answer your question, if those are both negative, then you probably have never had it, but you just don't know because you don't know if it's going to convert or not. Okay? All right, everybody. That's like all I got for now. Hopefully you've had a great weekend. Have a wonderful week. Please stay safe, wear a mask, and we'll see you next week, next Sunday, same time for some diabetes stuff. Have a good night, everybody.